Hello and welcome to another exam paper walkthrough. Today I'm going to be carrying on with my AQA predicted topic paper series, and this is going to be paper 3H that I am calling a most likely paper. So attached to the description to this video, you'll find a link to a Google Drive where you can download a copy of the paper. I would strongly recommend you've either done the paper before watching the video or do it alongside the video just to get the most out of it. I'd also recommend a bit of music on in the background just to make it slightly more enjoyable to go through. So this is in preparation for the June 25 examination series, and I've produced this based on the topic list from First Class Maths. If you've not already checked out the material from First Class Maths, I would strongly recommend you head in that direction. As well as the revision list, there's some fantastic topic videos, and very shortly you'll be able to access his 3H paper as well. If you find this video useful, please do subscribe if you like, and you'll get notified as soon as any other videos become available, including my breakfast warm-ups. Right, let's get started with the paper. Okay, question one. A shape is made by joining a right angle triangle and a rectangle. So work out the area of the shape. Kicking off straight away with a bit of Pythag. So we've got to work out this length here. So I'm going to call that X for now. Ooh, let's turn my pen on. So I'm going to call that X to start with. This will be the hypotenuse. So X squared is going to be equal to, I'll jump straight to the version of square root of 30 squared plus 16 squared. That'll give us X. Right, so then the total area of the shape, total area is going to be equal to the area of the rectangle, which would be 52 times by X, plus the area of the triangle, which would be a half of the base times the vertical height, so half of 30 times by 16. Right, let's bring the calculator up. So I'm using this model just because I quite like the emulator. If you're using a different one, it shouldn't really affect anything. Any questions where we're using a different function, I will discuss it. So I want the square root of 30 squared plus 16 squared. Which is going to give me 34. That's a nice, spotted that. We've got in triple there. The total area then is going to be 52 times by that answer. To that, I'm adding 0.5 times by 30 times by 16. So I'm looking at 2008 centimeters squared, sorry. So 2008. Right, question two. In a game, an ordinary fair six-sided dice is rolled. A fair spinner shown is spun. So we've got the 2x, 3x, and x squared there. Complete the table to show all the possible scores. The score is the dice number substituted into the spinner expression. Missed that word in. Complete the table to show. So all of these are going to be doubled. So I'm going to go 2, 4, 6, 8, 10, and 12. Then times them by 3. So 3, 6, 9, 12, 15, and 18. And then the values squared. So 1, 4, 9, 16, 25, 36. So player wins the game if their score is a 10 or more. Work out the probability that they will win the game. So if I just change colour slightly. So 10 or more, so we've got 1, 2, 3, 4. I've miswritten here. In. That was 18. So I've got 1, 2, 3, 4, 5, 6, 7, 8 of the options give us a score greater than that. So I'm looking at 8 out of the total number of outcomes, which are 6 times by 3, so 8 somewhere else. We'll go 8 out of 18, which would be 4/9 when simplified. The game is played 711 times. Estimate the number of games that are won. So we're going to do 711 times by the probability of winning, so 4 over 9. So 711 times by 4 over 9 gives us 316. Right. Question 3. A bowl is a hemisphere with a radius of 12. Water is poured into the bowl at a rate of 325 centimeters cubed per second. For 8 seconds, does the water fill more than 70% of the bowl? Okay, so I'm going to start by working out the volume of the hemisphere. So the volume is going to be equal to a half of the volume of the sphere. So that would be 4/3 times by pi times by 12 cubed. If we tidy that up ever so slightly, that would be 2/3 of 12 cubed pi. So we will, and so we'll do that. So 2/3 times by 12 cubed. I'm going to leave my answer in terms of pi for now. So 16 over 3 pi. Seem big enough? Yeah, there we go. 12. That looks more like it. So we've got a volume of 1,152 pi. I want to find out what 70% of that is, because does the water fill more than 70% of the bowl? So if I times that value by 0.7, that'll give us the volume of, well, that'll give us 70% of the volume. So we're looking at 4032 over 5 pi. And I'll go decimal on that in a second. No, I'll go decimal on that now. So if I times that answer by pi, that'll give us 2,533.38 and that centimeters cubed. Right, I'm now going to look at the amount of water that we would have after 8 seconds. So if I do 325 water times by 8, that will give us, so 325 times by 8 gives us 2,600 centimeters cubed. So that's the amount of water. That would be 70% of the bowl. So does it fill? Yes. Yes. 2,600 centimeters cubed is greater than 2,533.34 centimeters cubed. Right, question 5. John, Gilly, and Sam each have an amount of money. John has £72. John's amount to Gilly's amount is 6 to 5. Sam has 1.5 times John's amount. Show that in total they have less than £250. Okay, so I'm going to kind of help me structure this with a bit of a ratio table. So we know that John has £72. We know that John to Gilly's amount is 6 to 5. And we know that Sam has 1.5 times John's amount. Right, so I'll change pen then. So the first one I'm going to look at is, if we've got 6 to 5 here, to get from here to here, we times by 12. Divide by 12. So let's put my arrow the other way, because times by 12 is a bit more like what I'm after, really. So times by 12. So that means that 5 times by 12 is going to give me 60. So Gilly's amount would be £60. And then over here, then 72 times by 1.5 is going to give me 108. So I've got all three figures now. So let's see, 72 plus 60 plus 108 is going to be equal to, got 1 8 already, so plus 72 plus 60 gives me a total of £240 is their total amount. So £240 is less than £250. Okay, question 5. A times by b to the power 4 is equal to c. Circle the correct expression for a. So if I ignore all of them for now and say that then a is going to be equal to c divided by b to the power 4. So, and then let's look for that. So that's going to be that one. Right, question 6. Information about two fridge freezers. A and B is shown. Fridge freezer, total capacity, fridge capacity to freeze the capacity. B, fridge freezer, fridge capacity 295, fridge capacity to freezer capacity 273. Shay buys one of these fridge freezers. She buys the one with the greater freezer capacity. Which one is she going to buy? Show your answer. So if we look at A first of all, so I want the freezer capacity for them both. So we're given total capacity and we're given the ratio. So we want to split 330 into that ratio. So we've got 3 to 2. We're splitting 330 into that ratio. So if I do 330 divided by 5, that will give us 330 divided by 5. Each part is going to be worth 66. So I only want this part really though. So 66 times by 2 is going to give us 132. That's going to be my for fridge A. For fridge freezer B, this time you're given the fridge has a capacity of 294. So if we start 7 to 3, got 294 there. So to get from there to there, we're times in by 394 divided by 7. So I've mistyped there. 294 divided by 7. It's going to give me, right, so I've mistyped there. So I should have done a division symbol there. So 42, which means that the capacity of the second fridge is going to be 3 times by 42, which is going to give me 126. So the one that has the larger capacity is going to be fridge A. Sorry, fridge freezer. Fridge freezer A. So I'll just say A 132 is greater than 126. Right, question 7. Write 0.13 reoccurring as a fraction in its simplest form. So I'm gonna use algebra for this. So I'm going to say first of all that x is going to be equal to 0.13 reoccurring. So then I'm going to jump straight to saying that 10 lots of x is going to be equal to 1.33 reoccurring. And I've times by 10 just so I've got this reoccurring pattern. I'm then going to say that 9x is going to be found by doing the top one minus the bottom one, so 1.2, which means then that x is going to be equal to 1.2 over 9, which is the same as 12 over 90. Then I'm going to cancel that down. So 6's will go into them both. 6's will go twice into 15, and it will go 15 times. Just double check that though. Yeah, 2 over 15. If anyone's particularly interested, you could actually do this purely on your calculator, which I think the wording would be shown rather than So if I wanted to type that into my calculator, I can actually type it in. Struggles. Let me make my calculator a bit bigger. I've just spotted I haven't actually got a recurring decimal on this. So I was getting it confused with the other model. I'll bring the other model up in a moment. For this version of the calculator, what I would need to do is type the recurring digit in until we get the arrow button up here. There we go. So we've got the arrow button here, and that indicates that we've got enough digits for it to recognize that that's a recurring pattern. So that will give us 2 over 15. Right, I'm actually going to bring up the older model just because there we go. Uh, I think it's easier to type it on here because you've got this second function here. So if I wanted to type it in on this model, I would type in 0.1, then I would type shift and then this button. Uh, my shift didn't hit there. Shift and then this button, and then I can type in the reoccurring digit there, and that will simplify it. So useful tip just to know the difference between them. Okay, right, let's get back on with the paper. I will change back to the other model. There we go. No, that's the. I've changed back to the other model. There we go. Make it a bit smaller, and we'll move on with the paper. Okay, question 8 then. Here is a speed time graph for a 50-second journey. Circulate the acceleration in meters per second halfway through the journey. So halfway through the journey is going to be 25, which is going to be here. So technically speaking, we haven't got any acceleration. We're going at a constant speed, so 0. Work out the total distance traveled. So the total distance on a speed time graph is going to be the area of the area of the graph, which is the area of a trapezium. So the area is going to be equal to a half of the top length, which is 10 so 30, plus the bottom length, which is 50, times by the height, which is 20. So I'm going to do the half and the 20. So it's going to become 10 times by 80, which is going to give us 800. And that will be in meters. So yeah. Right, question 9. Here are the first 4 terms of a quadratic sequence. Work out an expression for the nth term of the sequence. Right, so I'm going to give myself a bit more working space. So for a quadratic sequence, I would always recommend rewriting the terms again, but giving yourself a bit of space above. Because for a quadratic, we're going to be looking at the second differences. So the difference between these two numbers is going to be 17. The difference between these two numbers is going to be 27. And the difference between these two numbers is going to be 37. And then my second differences then are 10 and 10. Right, so that means that we've got 10 over 2n squared in there. 10 over 2n squared in my sequence, so 5n squared. So if I now look at what 5n squared would give me, so let's do it here, 5n squared. So if n is 1, 1 squared is 1, times by 5 is 5. If n is 2, 4 times by 5 would give me 20. If n is 3, 9 times by 5 is going to give me 45. And if n is 4, 4 squared, 16. 16 times 5 is 80. Right, now I want to work out the difference between 5n squared and my original sequence. So the difference is going to be, what do I need to do to this to get to this? So minus 2 there, 0 there, plus 2 there, and plus 4 there. So this sequence is going up in 2s. So this sequence is 2n minus, what do I need to do to 2 to get to 4 minus 4? So that will give me minus 2, 0, 2, and 4. So my sequence is this plus this. So 5n squared plus 2n minus 4. Right, question 10. An approximate value of a root of an equation x can be found using the iterative formula. And then we've got a nice complicated iterative formula. Starting with the value of x1 is equal to 4, work out the value of x2 and x3. Okay, so nice straightforward way of doing this on my calculator is start by putting your first term in. Right, now wherever I've got an xn, I'm going to type in answer. And then that will take whatever value I've got and put it into the equation. So I want, and I can type it in just like this. So I want the cube root of 5 times by my answer squared minus 2 times my answer minus 3. Just double checking that everything that I've typed in is okay. Right, so every time I press equals, it'll give me the next term. So my next term, or x2, is going to be 4.101, 4.101 dot dot dot. And then my next one, press equals again, 4.1, those digits. Let's move that slightly. 4.177 dot dot dot. By continuing the iteration, show that the value of x is more than 4.25. So for this, I'm just going to carry on with this. For a cubic graph, well, for a graph of this sort. So our next value, our next value, our next value, and then we can see that we're now oscillating between my last value, which was 4.25 something, and so you can see that this is oscillating between those values. So we can say any value, we'll write that one down. So by continuing, show that the value so the value has to be between 4.38 dot 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 is a more accurate value. Go one more. So yeah, any value really. But as long as the values that you've written down is bigger than 4.25, that would be absolutely fine. Right, question 11. Work out the percentage increase from 80 to 280. Okay, so it's going to be change divided by original times by 100. So the change is going to be 200 divided by 80 times by 100, which I think is going to be 250. So 200 over 80 times by 100. So we're looking at 250% increase. Question 12. Here is a table showing heights of 60 athletes. Complete the cumulative frequency for this. So cumulative frequency just means that we're adding the previous frequencies together. So we've done. Okay, interesting. So they're adding on a 0 column, which is fine. So we've got 0 that are less than 150. So we've got 4, that's 0 plus 4 is 4. Then we've got 4 plus 12 is 16. We need to do 16 plus 35, which would give us 51. 51 plus 7 is 58. And then 58 plus 2 is 60. So that is. Right, part B, circle the class interval that contains the lower quartile. So it would be easier to explain this after drawing that, but we'll stick with this. So for For a cumulative frequency, what we do is if we've got 60 athletes, if we imagine kind of 0, 60, I'll call them Q1, Q2, and Q3. That's the quarters. So we would go for cumulative frequency, we tend to take the mid value, so that would be the 30th value. So we're after the 15th value and the 45th value. 30th, 45th. So the 15th value. 15th value is in this group between 170 and 160. So we're going there for the right. Draw the cumulative frequency diagram to represent this data. Okay, right. So I'm going to be flicking backwards and forwards a fair bit here. So we're saying 150 is 0, so 150 is 0. We're then going 160 is 4, so 160 is 4. We're then going 170 is 16, 170 is 16. 180 is going to be 51. We've then got 190 being 58, 190 being 58, and then 200 being 60. Check that. Yep. We then want to join that with as smooth a curve as we can. I'm not very good at drawing smooth curves on a screen. If I'm doing it on paper, I always like to keep my wrist on the inside of the curve. So that's going to be roughly my curve. Right, estimate the number of athletes whose height is more than 170. Sorry, 176. So 176 is going to be here. So we're going to go up to our curve from 176. Read across. So I'm making it roughly 40. So 40. 40 out of 60. So that would be 20 people that have a height more than 176. And I've written 20 there, but on my answer line I've written the 40. So I need to change that. There we go, that should be fine now. Question 15. A is equal to 65 to the nearest integer. B is equal to 30 to one significant figure. Work out the upper bound for 2a squared minus b squared. Right, okay, so if we think about this, if I want the maximum value for this, so I want the upper bound. So the upper bound is going to be equal to 2 lots of the maximum value for a squared minus the smallest that this could be. So minus, yeah, that's right. So minus b min squared. So if a is 65, then a max is going to be equal to 65.5. And I know technically we'd round that up, but in terms of bounds, we use that maximum value minus b min, which would be equal to one significant figure, that would be 25. So I'm going to type it in like that. So b, 2 lots of 65.5 squared minus 25 squared. So 2 times by 65.5 squared minus 25 squared. So I'm looking at 7,955.5. Question 16. Shape A is a circle with a radius of root 17 over 2 centimeters. Shape B is the sector of a circle with a radius of 5 centimeters. Which shape has the greatest area? A or B? You must show your working. Right, so I'm going to start with shape A. So shape A is going to be equal to pi r squared, which is going to be pi times by root 17 over 2 squared, which is going to give us 17 pi over 4. If I look at shape B, so shape B, not shape pi. I was going to say I'm going to leave my answer in terms of pi. So for shape B, that is going to become the fraction of the circle times by pi r squared. So that would be 1/6 times by pi times by 5 squared, which is going to give us 25 over 6 pi. So then it's just kind of which one is bigger than 17 over 4 or 25 over 6. So let's say then this one, it would be 4 would go into that fully 6 times. So that would be 6 1/4 pi. And then 6 would go into 25 fully. And I've miswritten here. It's not 6 1/4. 4s will go fully into 17 4 times with 1/4, so that's 4 1/4, and then 6 will go into 25 fully, 4 times again, but 1/6 pi. So which one has the greater area? That would be shape A. So I'll say A, so 4 1/4 is bigger than 4 1/6. Right, question 17, simplify fully. Okay, so I'm going to look at factorizing as I write this down. So I can actually take y out as a common factor here to start with. So we'll say y times by y minus 3 times by, then if I factorize the top line, it might be easier to factorize the bottom line first, because it's different 2 squares, so that's going to be y plus 3 times by y minus 3. I would imagine my prediction is that y plus 3 is going to be one of these brackets. So if we think two numbers that multiply together to make 21 and add together to make 10 is going to be 7 and 3. So plus 7 and plus 3. We can then cancel by quite a bit here. So we've got that will cancel with that, and that will cancel with that. So we're just left with y times by y plus 7. We could expand that, but I think that's nice and tidy. Right, question 18. A straight line passes through 3, 14 and 12, 32. Work out the equation of the line. Given your answer in the form y is equal to mx plus c. Right, so first of all, I'm going to say what the gradient is. So the gradient is the change in y, which is going to be 32 minus 14 over the change in x, which is going to be 12 minus 3. So 32 minus 14 is going to give us 15, 16, 17. 32 minus 14 is going to give us 18. So 18 over 9, which will give us a gradient of 2. Right, so that means that our equation must be y is equal to 2x plus c. And then we're going to use one of our points to find that value for c. I'm going to use the easier one, 3, 14. So when x is 3, y will be 14. So 14 is going to be equal to 6 plus c. So c is going to be equal to 8. So my equation on my line is going to be y is equal to mx plus c. So y is equal to 2x plus 8. Right, question 19. The nth term of a sequence is n times by n minus 4, all divided by square root of n plus 3. Work out the sum of the first and the seventh term. So if I put n is equal to 1 in first of all, n is equal to 1 first of all, that will give us 1 times by 1 plus 3, 1 minus 4 would give us minus 3. And we're dividing that by the square root of 1 plus 3, so 4. So that's going to become minus 3 over 2. Now, when n is equal to 6, I'm going to follow the same process. So that's going to be 6 times by 6 minus 4 is 2. And we're going to divide that by the square root of 6 plus 3 is 9, so 3. So that's going to give us 12 divided by 3. That's going to give us 4. So we want to do 4 plus, well, 4 minus 1.5. That's going to give us 2.5. 4 minus 3 over 2 is going to give us 2.5. Right, question 20, solve. So I'm going to assume that we can factorize this. So I'm looking for two numbers that multiply together to make minus 12 and that add together to make minus 1. So that tells me that one of the numbers is negative and it is the larger number. So I'm looking at minus 4 and 3. So x minus 4 and x plus 3. Meaning that my two values are when x is equal to make that bracket 0, x would need to be equal to 4. And to make that bracket 0, x would need to be equal to minus 3. Right, question 21. X and y are integers. Work out the largest possible value for y. Okay, so if I start with the first one, so x has to be less than or equal to 4x is less than or equal to 20. If I divide all three parts by 4, that means that 5. And then if we look at the y minus 3x has to be less than 12. So I actually want y, so I'm going to add 3x to both sides. So I'm going to say that y has to be less than 12 plus 3x. So for this, we want the maximum possible value for x. So that's going to be y has to be, so we're going to take x being 5. So 12 plus 15, which is going to be, so y has to be less than 27. So if y has got to be less than 27 and we want the largest it can possibly be, and it being an integer, I'm going to have to go for 26. Right, question 22. In the diagram, all the lengths are in centimetres. The two shapes have equal areas. Work out K to M. Right, okay, so if the areas are equal, what we can say then is the area of the first shape then is going to be equal to a half of 12 times by K, which is going to be 6K. Right, for this second shape, I'm looking for a logical way of splitting it. I'm going to split it down there. So for the second one, the area of the second shape is going to be 2 times K plus 3 times M. Right, and we're told that these two things are equal. So the way that I'm going to do that then is I'm going to say that 6K is going to be equal to 2K plus 3M, which means then that 4K is equal to 3M. Right. If I'm trying to view in my head, this is a ratio. The easiest way is to view it as K over M. So K over M is going to be equal to 3 over 4. And then if you've got it like that, you can say that the ratio of K to M is 3 to 4. Question 23. A race was run in 2019 and 2020. The box plot shows information about the finishing times in 2019. In 2019, what was the fastest time? So if we're talking about times in a race, we actually want the lowest value. That's going to be the fastest time. We're trying to read off this value. If we're going up in twos, so that's going to be 16 minutes. Part B, the table shows information about the finishing times in 2020. Use this data to comment on each of the following statements, and we've got an average and then a spread one. Right, so on average, so we're going to be comparing the medians. So the median for 2020 was 24. The median for 2019 was halfway between those two, so 22.5. So on average, they were faster in 2019. Correct. Median. Let's go right. Median is lower in 2019. And we'll put in 22.5 versus 25. They were equally consistent in 2019 and 2020, so I'm going to compare the interquartile range. So the interquartile range here, interquartile range is equal to 27 minus 21, which would be 6. Interquartile range here is 20 to 26, so 6 again. So the interquartile range there is also 6. So equally consistent, correct again. Correct. That's both have an interquartile range. Right. Quartile range of 6. Okay, question 24. Company makes and sells boxes of washing powder. Washing powder 1.68 kilograms for £5.60. The company wants to increase the amount of money it receives per kilogram of powder. To get the required increase, it can increase the price to £5.88 or reduce the mass of the box by X%. Work out the value of X to 2 decimal places. Okay, so for this, we're talking about price per kilogram. If we look at the price increase, so if we do 5.88 divided by 5.6, that's going to give us a price increase of 5.88 divided by 5.6. That's going to give us a price increase of 21 over 20. So as a decimal, that would be 1.05, but we're not really going to use that. What we can also talk about, or what we can also say then, is if we want to work out what we can change the weight. If we want the sum to remain the same, we would have to divide by that. So whatever the weight was, X, we would need to divide by, if you think about price per kilogram is price divided by mass, or so if we actually wanted to increase the mass, we would need to multiply by the reciprocal or divide by 21 over 20, which is going to be equal to times by 20 over 21. So as a decimal, that's going to give us then, so if I do 1 divided by my answer, that gives it, so we're talking about, that's what it would need to be reduced to 0.9523 ... So if we do 1 minus that, that'll give us the actual reduction, 1/20th. So we're looking at X, it's got to be equal to 0.047 61, so to two decimal places, it's going to be 4.76. Right, question 25. Work out the area of the triangle. So we're going to have to use, we're going to have to work out one of the other sides. I'm going to work out this side because I can use the sine rule for that. But it doesn't really matter because I'm going to have to, it still doesn't overly help, half a plus b sine c. So I'm going to have to work out the angle as well. So which order am I going to do it in? Doesn't really matter. Right, so I'm going to say first of all then that x over sine of 56 is going to be equal to 24 over sine of 73. So x is going to be equal to 24 sine 56 over sine of 73. I'm also going to say that theta is going to be equal to angles in the triangle minus the two known angles, which are 56 and 73. And then I'm going to use the area is going to be equal to half of AB sine C. So 24 times by x times by sine theta. Right. Okay, we'll go and use our calculator a little bit now. So the area is going to be a half of. Right, 180 minus the two known angles, so 56 plus 73 is going to give us 51. And then I'm going to leave it like that for now. So half of 24 times by x times by sine of 51. Right, so let's work out x. 24 lots of sine 56 divided by sine of 73 is going to give me that. So my value for the area is going to be 0.5 times by 24 times by my last answer times by sine of 51. So we're looking at 194.0318 for now. And what does the question say? It doesn't say to a specific degree of accuracy. Two significant figures, two significant figures, two significant figures. So three significant figures would be absolutely fine. So I'm going to go 194. We'll go one decimal place, 0.0. Right, question 27. Line A is perpendicular to line B. The gradient of line A is -2. Work out the gradient of line B. So if the lines are perpendicular, we need to see -2 times by x has got to be equal to -1. So it's going to be the negative reciprocal, which in this case is going to be a half. Right, question 27. Sansa has the following question in her homework. The net of a box is made by cutting 4 squares from a piece of cardboard. Cardboard is in a rectangle with width of x centimeters and a height of x plus 5 centimeters. Each square has a side of 10 centimeters. The area of the net is 1000 centimeters squared. Work out the value of x. Show that Sansa can form the equation. Right, so what I'm going to do is I'm going to say the total area would have been x times by x plus 5. From that, though, we need to take off 4 of these squares, so minus 4 lots of 10 times 10. And that has to be equal to 1000. Right, so that's going to give me x squared plus 5x minus 400, and that's going to be equal to 1000. So x squared plus 5x minus 1400 has to be equal to 0, which is what we were asked to show. Right, part B. Sansa correctly factorizes the equation to get x plus 40 times by x minus 35 is equal to 0. Answer to the homework question is x is equal to minus 40 and x is equal to 35. Is her answer correct? So that would be the correct roots to that equation. So when x is 40, that would be 0. When x is 35, that would be 0. So that is correct. But we're going to have to say no. Reason being, if this length is x, it's a length. We can't have a negative length. So x can't be a negative value. Can't be negative. So our answer should just be 40. Right, question 28. B is 2/3 of C. So B is equal to 2/3 of C. A 5A is equal to 4C. Work out the ratio of A to B to C, given your answer in its simplest form. Okay, so if I say that 5A is equal to 4C, my preferred method for converting equations into fractions is to put them as fractions over each other. So A over C is 4 over 5. So that means, and we'll do it here because I'm going to put some other working in, A to B to C. So the ratio of A to C is 4 to 5. And then if I do a similar thing here, I've got B is equal to 2/3 of C. So that means that B over C is equal to 2/3. So B is 2 and C is 3. So to combine these, I need to use C as my combining point. So to do that, I'm timesing this ratio by 3, so that would be 12, and this ratio by 5, so that would be 10. So I'm looking at 12 to 10 to 15. Question 29. Work out how many 5-digit codes can be made using 3 digits, using these digits once each. 1, 2, 3, 4, 5. Okay, so it's so 5-digit odd numbers. So that's going to be our key here. That they're odd numbers can be made using these digits each once. So I've only got 2 odd digits. So my digits either need to end in a 9 or end in a 7. So let's just imagine that my digits ended with a 9. So the number of digits that can end with a 9, so I can have any of these 4 for my first digit, then any of the 3, then any of the 2. So that's going to be equal to 4 times 3 times 4 times 3 times 2. So there's going to be 4 times 3 times 2. So there's going to be 24 combinations that end in a 9. If I do the exact same thing and imagine it was 7, then my choices are I can pick any 4, then any 3, then any of the other 2. So there would be 24 combinations that end in a 7. So in total, there's going to be 48 possible combinations. Question 30 here is a sketch of a speed time graph for the first part of a journey. The total distance for the journey is 130 kilometers. How far is left to travel? Okay, right. Um, so this should be the area. Could work these out separately, or I could work it out. Could work out total distance traveled by each section. So I'm going to work out the area of the whole thing. So I'm going to say that the area of the whole thing is going to be equal to 102 times by 60 minutes, which would be 1 hour. From that, I'm going to take away the area of these two triangles. So the first triangle then is going to be equal to a half of the base, which is 5 minutes, which would be 5/60ths of an hour, times by the height, which is 102, minus, this is 15 minutes, so that's going to be a half of 15/60, or a quarter, times by 6. Right, so as a calculator, I can pretty much do this, although this will tidy up quite a bit, hopefully. So let's go 102 minus 0.5 times by 5/60 times by 102 minus 0.5 times by a quarter. I didn't spot that. Times 6. That gives us 97. So 97 kilometers have been travelled. The total distance for the journey is how far is left to travel. So I'm going to do 130 minus 97, which is going to give me 33 kilometers left. Okay, question 31. The volume of a sphere is, volume of a cone is, the sphere has a radius of 2x, the cone has a radius of 3x, a perpendicular height of h. The sphere and the cone have the same volume. Work out the radius of the cone to the perpendicular height of the cone, giving your answer in the form a to b, where a and b are integers. Okay, right, so let's start by saying the volume of the sphere is going to be 4/3 times by pi times by the radius, which is 2x, times by 2x cubed. We'll tidy that up. So that is going to be 2 cubed is 8. 8 times by 4, 8, 16, 24 over 3 pi x cubed. Right, let me just double check that in my head. 2 cubed times by 4/3 does equal, yeah, there we go. Thought I'd done something wrong. 4 times by 8 is obviously 32. Right, so that's the volume of the sphere. The volume of the cone then, so I'll put BS for that. And then the volume of the cone, VC, is going to be equal to 1/3 times by pi times by r squared, so times by 3x squared times by h. Right, so that's going to be 9 divided by 3 is 3, so that would be 3 pi times x squared h. Right, we're told that these are equal, so 32 over 3 pi x cubed is equal to 3 pi x squared h. I'm going to cancel pi. I'm also going to cancel x squared, and I'm going to times through by 3. So 32x is equal to 9h. So that means then if we're doing radius of the cone to perpendicular height of the cone, right, so there's no point in actually going with x and h because actually we're dealing with a and b. So a and b, where b is h, perpendicular height, so h, but a is 3x. Radius of the cone. Radius of the cone is 3x. Right, so if I kind of replace these, I can replace h with b straight away, so 9b, but I can't replace h. I can't replace. So instead of x, if I divide this by 3, that would give me 30. That would give me 32 a over 3. So if I tidy this up a bit, so 32a is going to be equal to 27b. Now I want a to b, and again, I find it easier to view it as a over b is going to be equal to 27 over 32. So the ratio is going to be 27 to 32. Okay, and that's the end of the paper. So thank you very much for joining me in doing this paper. I hope you found it useful. There's some nice tricky questions towards the end of that paper. Other than that, if you've got any questions, comments or feedback, please type it into the description to this video and I will get back to you fairly quickly. Please do subscribe if you like. You get any notifications as soon as any other material becomes available, including my breakfast warm-ups. Other than that, good luck with the rest of your revision and good luck with your exam. I'll see you soon.